Hello everyone. Today I want to talk about my homework. Homework 3, exercise 3.1. Write a C hash to control C++ language by control temperature sensor. This homework has three main goals. First, make the C hash program and Arduino talk to each other through several ports. Second, use the DH11 sensor to read the temperature, show it in real time on the CH interface, and save past date. Third, learn how hardware and the software work together across different language and device. Uh, we need, we need these hardware parts for the system. Arduino Uno board runs C++ code DHT11 temperature sensor collects temperature data. Adapter wires connect sensor and board. USB cable gives power to Arduino and let it talk to the computer. And a computer runs the C hash program. Hardware connection. Now let's see how to connect them. Connect the HT11 VCC pin to Arduino 5V for power, ground pin to Arduino ground for grounding, and the date pin to Arduino digital pin 2 for date transfer. Important, the connections must match the pin number in the Arduino code later. Otherwise, it can't read date. Arduino code. This is start of the C++ code for Arduino. First, we define two pin setting. HT pins is the date pin set to 2, same as our connection, and the DHT tab tell the code the sensor is DHT11. Finally, we create a DHT object to let the code control the sensor. This is the core of the Arduino code. The setup function runs once to prepare several begin 9,600. Starts several communication with a baud rate of 9,600. This number must be the same as in the C hash code. DHT point begin starts the sensor. The loop function runs again and again. First, it reads temperature into variable point t. If it fails to read, it skips. If successful, it sets the temperature to the computer via several ports. Finally, delay 2,000.2 seconds because the DHT11 sensor needs time to prepare next date. It can't read too fast. We use Visual Studio to make the CHash program. It's a Windows Forms application. There are 4 key ports on the interface. Common box shows the computer's several ports like COM3. Button. The connect button to open or close the several port. Text box shows correct temperature in real time, and the list box saves past temperature date with time, so we can check old value. This is the start of the C hash code. First, we add the system I/O ports namespace. It is the key code for several communication. Then the form constructor runs automatically when the program starts. It gets all available several ports on the computer and adds them to the common box. If there are ports available, it selects the first one automatically to make it easy for user. This code runs when the user clicks the Connect button. First, the program checks if the serial port is selected. If not, it tells the user to choose one. If yes, it sets the serial port name for the serial port object. Open the port and start the timer. It also changes the button text to connected so the user knows the status. We use try check to handle problems like if the port is busy. It will tell the user the connection failed and won't let the program crash. These two code parts receive date and update the interface. The serial port date received event runs when the serial port gets date from Arduino. It reads date until the new line character matches Arduino's print. Remove extra space and saves it to a temperature variable. The timer tick event runs every short time. It shows the temperature in the text box and adds a time-stamped record to the list box. This lets us see the real-time date and past records. Important update: the interface needs cross-thread operation to keep the program running smoothly. This is system workflow. The system works in 5 steps. Step 1, connect all hardware and pour the WinRAR diagram. Step 2, use Arduino to upload the C++ code to the Arduino board. Step 3, run the CH program, choose the right serial port in common box, and click Connect. Step 4. Arduino reads temperature every 2 seconds and sets it to the computer via serial port. Step 5. The CH program gets the date, updates the real-time temperature in the text box, and saves past date to list box. Let's summary the key knowledge. Hardware part learn how the DT11 sensor works, how to connect it, and Arduino's pin functions and several port use. Software port for Arduino C++, learn to add library and set up several communication. For C hash, learn to use the several port class and event driving programming, like date, receive event, and terming event. And the correlation part, the key is to make date transfer work between C hash and C++ different language, and computer and Arduino different device. Make sure setting like baud rate and the same to set the date correctly. In short, I have finished a complete temperature monitor system. It collects temperature from hardware, sets it via several ports, and shows state in the software and save date in software. All three main goals of the homework are achieved. And the demo video will show three things. One, hardware connection clear show if the DHT11 sensor is connection to Arduino correctly. Two, Arduino operation prove the C++ code is uploaded to the board successfully. 3. Say hash program running. When the open the program, the command box load available several ports. Automatically, after click connect, the button text change to the connect. 4. Temperature display. The text box updates current temperature in real time, and the list box saves each temperature every 2 seconds in time. Temperature format, no data loss or errors. 5. Disconnect test. Click the button to close the several port normally, and the uh, program won't crash. The whole daemon will prove the system is stable and works well. Let's look at the video. That's all for my homework. Thanks for your listening. Goodbye.